Okay, sorry about that. That was a malfunction on the camera. Okay, I'm back. Okay, so you're like, well, how do I enter in 1 2/3? You don't. You need to make a 3, okay? And you're going to take the whole number. You make a 3 on the bottom. You're going to have 3 on the bottom. Then you take 1 times 3, which is 3, and then add 2. So it's 5/3. So 1 times 3 plus 2, okay? Now I can subtract 5/3 minus 3/4. Okay, I got 11/12, okay? So it's x to the power of 11/12. Okay, now obviously you can't get rid of the fraction because you don't even have a radical with 12 in it, okay? And x wouldn't be there anyway. So I make a radical of 12 and I put x to the 11th, and I wouldn't be able to simplify that. That would be the answer. Okay, next up, 27 to the negative 2/3 power. So you got 27, 1 times negative 2/3 is negative 2/3, but you need to rewrite this because with the negative exponent, it needs to go to the bottom and a 1 needs to come over the top of it. So you can bring the 1 straight over. Now how about, can I get rid of the third on the 27 right away? Well, let's look at our cubed root, see if 27's there. Oh yes, I can, it's 3. But you don't just put 3 over here. You have to take 3, it's 3 to the second. Okay, because there was a 2 on top. 3 to the second's 9, so it's 1/9. Okay. Okay, next one. Y to the power of 1/5 times y to the power of 1/2. So rewrite it without the fractions. You need 2 parentheses again. Reason why is because you have different numbers on, or actually no, we don't need the parentheses. We want to just roll like this, okay? I don't have any radicals, so that's a good thing. So y, and then you're going to add 1/2 plus 1/5 plus 1/2, okay? So 1/5 plus, switch the operation to plus 1/2, okay? 7/10, okay? So y is to the power of 7/10. I wouldn't be able to eliminate the fraction right away, so I would make a 10th root and put y to the 7th inside. There's no simplifying to that. That would be your final answer, okay? Okay, next one's kind of a bear. You have 64, x to the 4th, y to the 4th on top, and then 125, x to the 2nd, y to the 18th, and then 2/3, okay? Okay, alright, so on top you got 64 times x times y. On bottom we have a new base of 125. So 1 times 2/3 is 2/3. And the same thing happens with the 125. 1 times 2/3 is 2/3. Now on the x, we need to take 4 times 2/3 first. So 4/1. Switch the operation to times 2/3. Calculate 8/3. You want to go at 2 2/3 up. You want the mixed number, okay? Or actually hold that thought, okay? Yeah, go 2 2/3. But then we have to minus the x that's on the bottom. 2 times 2 2/3, okay? 2/1 times 2/3. Okay, we got 1 1/3. So 2 2/3 minus 1 1/3. If you got one of these calculators, that works. Okay. However, actually, tell you what, make another Google page. Okay, go to another Google search and go mixed number calculator. Mixed number calculator. And do the first one. Okay, mixed number calculator. Okay, then that should be easier. Okay, So 2 and then space 2 divided by 3, and then we're going to minus, so make sure you switch that to a minus. You're going to do 1 and 1/3. Okay, 1 and 1/3 is what you got. Okay, so cross that out. And put 1 and 1/3. Okay, now the y is going to be similar. You're going to take 4 times 2/3. Let's see if this will just work right here. 4 times 2 divided by 3. 2 and 2/3. Okay, so you're going to have 2 and 2/3, but then you have to minus 18 times 2/3. Okay, you got 12. Okay. Now take 2 and 2/3 minus 12. Okay, negative 9 and 1/3. Okay, well we need to rewrite this problem then because I had a negative power. So all the positive powers all stay the way they are. The x stays where it is because it's 1 and 1/3. The y goes to the bottom where it becomes 9 and 1/3. Okay? Actually, hold on a second. 18 and 1/3. Do me a favor, guys. Can you do this, please? Can you please switch the power of 4 to a power of 3, please? So if you take 3 times 2/3, that's going to give you 2. And then if you take 2 minus 12, it's negative 10. It'll make things a lot easier. Y to the 10th. Okay, now look at the bases. Get rid of some of these fractions. The third. Okay, if you look at the cubed root, 64 is there. So I can rewrite that as 4 to the second. Okay, x isn't going to be here. So the x to the 1 will go over. You get rid of it, okay? We'll deal with the 1/3 here in a second. Okay, let's look at the 125. Is that cubed? Yep, that's 5. So it's 5 to the second, though. 5 to the second. And y to the 10th can just be brought straight over. Now, the only fraction I couldn't get rid of was that 3 with the x. So I make a cubed root, and I just put x to the first, okay? So 4 to the second, 16. X. Got the cubed root of x, if it's to the first, and then bottom 5 to the second is 25, and then y to the 10th. Okay. Switch that problem up a little bit. Okay. All right, next problem. We've got the cubed root of 2x on top of a fraction and the cubed root of 2y on the bottom. So you can just make one parentheses because it's all both cubed roots. If they're both the same, don't make two separate. Just make one big one. So you got 2x on bottom, you got 3, or 2x on top, 3 on bottom. Take all these to the 1/3 power. You got 2 to the 1/3 times x to the 1/3. Then on bottom, you're going to have 3 to the 1/3. No negatives, so you don't have to rewrite the problem. Now, third cubed roots, I don't think 2's there to get rid of right away. I don't think x is there, and I don't think 3 is there. But you can't have a fraction on the bottom, so here's what you need to do. You need to make a plus sign, and what would you have to add to 1 to get 3 whole? 1 plus what number is 3? Well, it's 2, okay? So if I add those, it's 1, so 3 to the first. Now, you got to bring to the top a factor of 3 to the 2/3 power. Whatever's the exponent you just made up, you got to bring the base and that power to the top, okay? So now 3 to the 1 just goes straight over. Now, I can't get rid of any of these fractions, so I make a big fraction right there. And 2 to the first times x to the first times 3 to the second. So 3 to the first is 3, and I make a cubed root right there. And then I'm going to have the x inside of it for sure. And then I need to figure out what I can do with the cubed root of 2 to the first times 3 to the second. So 2 to the first is 2, 3 to the second is 9, so that'd be 18, okay, cubed root of 18. Is 18 going to be divisible by any of these? I don't think so, so I just put 18 inside, and that's all she wrote. Okay, now it says game change on your Google Doc, okay? 18 square root of 3m minus 25 square root of 3m. Okay, game change. When you have a minus or addition, you don't make the 3 lines, okay? What you do is you check the inside of the radicals. They're the same, so you put that radical down, and then you subtract the outsides. 18 minus 25 is negative 7, okay? Now, what do we do if they're not the same? Okay, well, we're going to make kind of a chart off to the side. I'm going to do square root 75. Remember, it's a 2 if you don't have it. Don't try to rewrite it. You want the radical when adding and subtracting. 5 square root of 3. Okay, you'd be on your square root. 75 divides by 25, so I make 2 square roots, and I put 25 and 3. So that's 5 square root 3. Plus, okay, you need to drop your 2. You can't forget about the 2. So 48 is divisible by the perfect square of 16. 48 divided by 16 is 3. Square root of 16 is 4. So 2 times 4 is 8, square root 3. Minus, and then 3 I don't really think divides by anything, so that's going to stay the same. Now I have the same thing under the radical. I've got square root of 3, so I take 5 plus 8 minus 5. That's 13 minus 5 is 8, so it's 8 square root 3. Okay, my next problem. 3 plus 2 square root 2 times 8 minus 5 square root 32. Okay, it's going to be the FOIL method. We got a plus here, a minus here, but you need to simplify the radicals that are possible to simplify. Now, the square root of 2 can't be, okay? How about 5 square root 32? Well, I drop the 5, and 32 is divisible by 16, so I can go 16 and 2. Now, 5 times 4 is 20, 20 square root 2, so cross that out and put 20 square root 2. Now you FOIL. You're going to take 3 times 8. You're going to take 3 times negative 20 with square root of 2. You're going to take 2 square root of 2 times 8, and you're going to take 2 square root of 2 times negative 20 square root of 2. Okay, so 3 times 8 is 24. 3 times negative 20 is negative 60 with square root of 2. Square root of 2 can't be simplified. 2 times 8 is 16 with square root of 2. 2 times negative 2 is negative 40, and now you multiply the square root of 2's, which would be the square root of 4, but the square root of 4 is equal to 2. So this is actually equal to negative 40 times 2, which is negative 80. So these are the products I got. That last one can always be simplified. You would want to combine these. You would want to add 24 to negative 80. 24 plus negative 80 is negative 56. And then you would also want to combine these because they both have a square root of 2. So negative 60 plus 16 is negative 44, square root of 2. Now don't do anything else. That is simplified. You can't do anything else. You can't do a subtraction operation when that has a square root of 2 and that doesn't. It's done. Okay, then we're solving equations for x. Okay, the first one's pretty easy. Square root of x plus 5 plus 2 equals 4. First off, underline your radical. Okay, and it's a degree 2. First off, you got to get rid of the operation outside the radical. Minus 2, that's 2. Now you're going to get rid of the radical. You parenthesize both sides, and you take them both to the power of the radical degree. x plus 5, and then 2 to the second's 4. Okay, then you just subtract 5 and you got your answer. X would equal -1. Okay, next problem. This one takes a little bit more time. Square root of 3x plus 3 equals x plus 1. Okay, I don't have any operations outside the radicals, so I go to my second power. This side cancels and becomes 3x plus 3. This side is a little more complicated than just 2 to the second. You need to make a little box and write FOIL, and you need to take x plus 1 times x plus 1. So I take x times x times 1, 1 times x, 1 times 1. X second, 1x, 1x, and 1. That adds to 2x, okay? So I got x squared plus 2x plus 1. So there's going to be two answers to this, okay? Because it's a quadratic equation. It's got two answers, okay? Now, you want to get rid of the stuff over here. You want to keep the x squared. So we're going to minus 3x from 2x, minus 3 from 1. So we have 1x to the power of 2 minus 1x minus 3 equals 0. Or minus 2, my bad. 1 minus 3 is 2. Okay, GCF table. The GCF, you wouldn't have a GCF on that. 1 would be your GCF. So I guess it would be table time. 1 times -2 is -2. We're trying to add the two factors to get to -1. So it's got to be a positive times a negative. 1 and 2 does the trick. Okay. And that adds to -1. A is a 1, so you don't have to worry about that. So you got x plus 1 times x minus 2 equals 0. So minus 1, you get -1, plus 2, you get 2. Okay, so x equals -1, -2. Okay, the last problem in this assignment, you got 4, parentheses, x minus 2 to the 2/3 power equals 16. Okay, we need a q. When I have a whole parentheses to a power, I want to get rid of the parentheses. I use q to the 2/3 power equals 16, and then I'll use my table over here. Now, look at your top. If it's even, you need both sides. If the top is odd, you need 1. Well, it's even, so we need 2. Okay. So you're going to divide by 4, and that's 4. Now, when you get rid of a fraction power, you actually take each side and flip the fraction over. You flip it to 3/2. Now, what's 4 to the 3? See if you can get rid of that 2 with the 4 on the spot. I believe you can. 4 is a perfect square. It equals 2. So 2 to the 3rd, 2 times 2 times 2. So that's gone. We now have 2, because the square root of 4 is 2, to the 3rd is 8. Plus 2, I get 10. Plus 2, I get -6.